Welcome back to my YouTube channel on Sagacious Learners. In this video, we're going to be talking about naming of alkanes. But before we dive into naming of alkane, we have to explain some concepts in order to avoid confusion. So first, let's talk about carbon. So this is carbon. And in naming of alkane, you have to see something like this in naming of alkane. So you ask yourself, what is this actually? But before I explain this is methane. Don't get confused. But before I explain this, let's talk about more about carbon. So what is carbon? Why is carbon 4? Why is oxygen 2? Why is hydrogen to hydrogen bond 1? And why is nitrogen 3? Also, we're going to talk about why hydrogen and chlorine bond is 1. So first, let's talk about carbon. Carbon has 4 valence electrons. So in order to obey the octet rule, carbon has to gain 4 electrons. Carbon has to go to covalent bonding because carbon are metalloids, so they can behave as metal and they can behave as non-metals. So they are in group 4 in the periodic table. Carbon need 4 electrons in order to obtain a noble gas structure or to obey the octet rule. So to do this, carbon has to go towards 4 bonding. Carbon has to have 4 electrons, and to do this, carbon has to go in towards 4 bonding. So let me explain this 4 bonding. Has to go over to covalent bond. So in order to go over to covalent bond, oxygen has to obtain the octet rule. This octet rule, oxygen is in group 6 of the periodic table. So oxygen needs only 2 electrons in order to balance itself. That is why you have oxygen as -2, because oxygen will gain 2 electrons in order to obey the octet rule or obtain the noble gas structure. So oxygen will go over towards covalent bond with maybe hydrogen elements in the periodic table in order to obtain the octet rule. So this bond is 2. It has to go over to covalent bond, which means oxygen have to bring 2 electrons, and the elements which oxygen is bonding with has to also provide 2 electrons for them to bond. So if the electrons are shared equally, it is referred to as pure covalent. Now you have the basic understanding of covalent bonding. In hydrogen exists as a diatomic gas. Why? Because hydrogen go to covalent bonding with hydrogen itself. So where one hydrogen will bring 1 electron and the other hydrogen will also bring its own electron, they will bond together to form a bond. In double bond, we have 1 pi bond, 1 sigma bond, and in a triple bond, we have 1 sigma bond, 2 pi bond. Let me repeat what I said. In a single bond, we have 1 sigma bond. In a double bond, we have 1 sigma, 1 pi bond. In a triple bond, we have 2 pi bond and 1 sigma. And a sigma bond is harder than a pi bond, but 2 or triple pi bond is harder than a sigma bond. So considering breaking a very strong pencil, a single pencil, than trying to break 3 pencils at once, so which one will be harder to break? Is it the single pencil or the triple pencil? So the triple pencil will be more harder to break when compared to the single pencil. Let's go over to what we have in naming of alkane. In naming of organic compound, the first homologue in the homologous series of hydrocarbons is alkanes. So alkanes have general molecular formula of CnH2n plus 2. This general molecular formula, an alkane differs with or a trend with CH2. I'll explain this later, but let's talk about this formula we have in our front. So what is CnH2n plus 2? CnH2n plus 2 is the general molecular formula of alkane. So one or a single alkane is referred to as methane. So N can be equals to 1, 2, 3 to any number. So let's consider N being equals to 1. So if N is equals to 1, so what do we have? We have C1 H 2 times 1 plus 2. So this one is not necessary now. I'm going to put CH 2 times 1 is 2 and 2 plus 2 is 4. So the first member of alkane is called methane. Let's bring back our formula again. In naming of alkane, you're going to just put the prefix or suffix ANA at the end. So we have methane because this is alkane. So we're going to add this to this. So we're going to call it methane, having a formula of what? CH4. So what of if N is equals to 2? We have CnH2n plus 2. So if N is equals to 2, so C carbon become 2, H bracket 2 multiplied by 2 plus 2. So I now have C2H4 plus 2. So I now have C2H4 plus 2 is 6. So this is called ethane. This is Earth, but due to it is we are naming alkane, we are going to add this word to this. So we now have ethane, which has molecular formula of C2H6. So I'm going to do more last example, and I'll go straight and write the first 10 members of alkane. So let's consider if N is equals to 3. If N is equals to 3, we now have 3H. So 2 times 3 is 6 plus 2. So I have CHH8. So this is referred to as what? Propane. This should have been pro, but due to naming alkane, I'm going to now add the prefix or suffix ANA. So this is now called propane. Now you know how to name alkane. I'm going to write the first alkanes, the first members of alkane, the first 10. So this is CH4, which we call methane. This is C2H6, which we call ethane. So this is C3H8, which we call propane. So this is C4H10, which we call butane. So this is C5H12, which we refer to as pentane. So this is C6H14, which we refer to as C6 is hexane. So this is C7H16, which we refer to as heptane. This is C8H18, which we refer to as octane. This is C9H20, which we refer to as nonane. This is C10H12, which we refer to as decane. So you see, because the naming of alkane, they ended with ane. So earlier in this video, I said alkane or successive alkane differs with CH2. So this is methane. So add CH2 to methane, we have ethane. One carbon atom plus one carbon atom, we have two carbon atom, which is this, and 4 plus 2, which is what, 6. Okay, add this CH2 to this, we now have 2 plus 1, we now have 3 here, and 6 plus 2, we now have 8. So if you look at this, you see that this is moving in a trend with a successful formula of CH2. So successive alkane move with a molecular formula known as CH2. So before naming complex alkane, I would like to introduce something to you. Let's talk about the alkyl group. So alkyl group has general formula of what? CN H2N plus 1. So if I have N equals to 1, so my first member of alkyl group is called methyl. This is 2 times 1 will give me 2 plus 1, I have 3. So this first member is referred to as what? Methyl. This is an alkyl group. This is no more alkane. Since because of this is an alkyl group, we are going to be this. In methane, we have this. So I'm going to remove this and add HY because it's an alkyl group. So our second member, let's say N is equals to 2. So I now have, bringing back our formula, here will be 2. Here will be 2 times 2 plus 1. So I have C2H what? 2 times 2 is 4 plus 1, which is 5. So my second member of the alkyl group is called ethyl. Now you have understand the thread of this compound. So what will be my next compound? My next compound is called what? Propyl. So this is how it works. So keep on using this formula and keep on trying and bringing out more formula as you can. So let's go over to naming of alkanes with substituents. Before we start naming of alkane with substituents, let's write this structure. Let's talk about drawing Lewis structure, how to expand Lewis structure. So we have our first member to be what? Methane. And methane has general molecular formula of CH4. So how can I draw this? How can I draw the Lewis structure of methane? So drawing the Lewis structure of methane, first you draw your carbon. Since carbon goes into what? 4 bonding. Carbon has to undergo 4 covalent bonding. So what is this 4 covalent bonding? This, and this. Now we have 4 hydrogen. So this is now H, hydrogen, hydrogen, and hydrogen. So this is the structural formula of methane. What of if we have ethane? How are you going to draw the structural formula of ethane? So drawing the structural formula of ethane, ethane has general formula of C2H6. So how am I going to draw the structural formula of ethane? Since I have 2 carbon atoms, I will now draw my single covalent bond between the 2 carbon atoms. Remember, carbon has the ability to catenate. Catenation is the ability of carbon to form carbon to carbon bond, carbon single bond, or maybe a triple bond. So how many hydrogen is here? We are going to distribute this hydrogen equally because carbon and carbon, they are the same. They have the same partial electronegative dipole moment. I have hydrogen, I I have hydrogen, I have hydrogen, I have hydrogen, and I have hydrogen. So is this complete? Carbon form 4 bonds. So let's count. This is the first bond. This is the second bond. This is the third. And this is the fourth. So my structure on the left is correct. So let's go back to the right. This is my first bond. This is my second. This is my third. And this is my fourth. So this structure is correct. It obeys the octet rule. Let's talk about butane. How are we going to draw the structural formula of butane? Butane. Butane has molecular formula of C4H10. Recall, this is our formula. So this is the structural formula of butane. So butane have 4 carbon atom. So what are we going to do? First, we're going to draw our 4 carbon atom. Let me create some more space. So these bonds are called, this is the ability of carbon to catenate. So since I have 4 bonds, what is remaining? 10 hydrogen. So let's start adding the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So is this correct? I have 4 carbon and this is definitely 4. 1, 2, 3, 4. And I have 10 hydrogen and the hydrogen here is 10. So let's check whether our carbon is correct. Carbon has to form 4 bonds. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. So our structure is correct. Let me draw the last one. Let's talk about how to draw decane. So decane has molecular formula of C10H22. So how am I going to draw this? I'm going to first draw the 10 carbon atom, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1. I have 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So all the carbon atom here obey the octet rule because they have 4 covalent bonding. So what of if we have oxygen? Oxygen is in group 6 in the periodic table. So oxygen will form 2 bonds. That is why in drawing the structural formula of water, we have something like this. Because oxygen will go over to 2 covalent bonding with hydrogen atoms, having a bond angle of 104.5 degrees. Let's consider drawing this. No. So here is a question for you. So is this structure correct? Yes or no? Yes, this structure is correct. Why? Because carbon has to obey the octet rule. Now we have 1, 2, 3, 4 as the first carbon here. And how many bond is here? 1, 2 plus what? 2 double bond between the carbon and oxygen atom. So this is definitely correct and others are 4. So our equation is correct. So let's try naming compounds. Substituents. Naming of alkane compound with substituents. So here is a question for you. So your first question is expand this structure. To expand this structure, we now have C3CH and my methyl. So let's go and expand this structure. So expanding this structure, carbon has to form 4 bond, which is the 3 hydrogen. Now carbon to carbon bond, I have my H and I have my methyl group. This is called methyl, the first member of the alkyl group. And I have my carbon bond and I have H and hydrogen. So what is the Iupac nomenclature of this compound? So try naming this compound. First, how are we going to name this compound? We have a substituent, which is this. If that hydrogen was there, we're going to just go straight and call this propane. But now we have a substituent called methyl. So are we going to number from backward or forward? So numbering backward or forward won't affect the Iupac nomenclature of this compound. It won't, because it is in the middle of the carbon atom. We have 3 carbon atom. So how are we going to name this? So I'm going to assign numbers to the parent's continuous chain. So the parent's continuous chain is propane. I have 1, 2, and 3. So this we now have. I have here propane because we're naming alkane hyphen. I have a methyl group attached towards my carbon 2 atom. What am I going to do? So I'll call this 2-methyl propane. Let me write this very well. This is 2-methyl propane. What of if we have something that looks like this? How are we going to name this compound? So how are we going to name this compound? Will we number this then from the back or from the forward? How are we going to name this compound? As I said, it will move in this direction. Why? We are moving in this direction. We are moving from right to left because we want to give the substituents. These are called substituents. We want to give the substituents the lowest possible number. So if I should decide to number from left to right, so here we become my 1, 2, 3, 4. So I will now have 3, 4 methyl, but if I should number from here 1, 2, 3, 4, I will have 1, 2 methyl. So between these two numbers, which one is bigger? Is it 3, 4 or 1, 2? You see that 3, 4 is bigger than 1, 2. So we're going to use the smallest number because our aim is to number and give the substituents the lowest possible number. So the lowest possible number here is 1, 2 and not 3, 4. Because if you number from left to right, definitely we are going to fail this question. But if you number from right to left, you're in the correct track. So how are we going to name this number? So let me introduce something to you. If we have two substituents, we are going to refer it as die. If we have three substituents, we're going to refer it as tri. If we have 4, we're going to refer it as tetra. If you have 5, penta. If you have 6, hexa. If you have 7, hepta. If we have 8, octa. If we have 9, nona. And if you have 10, deca. So we have two the same substituents. How are we going to name it? So we're going to now write first 1, 2. If you have number to number, you're going to separate it with a comma sign. But if you have number and alphabet, you're going to separate it with hyphen. So we now have 1, 2 dimethyl. Why this di? Because the two substituents are the same, they are identical, there is no difference. So we're going to refer it as, this is the first member of the alkyl group, so we're going to refer it as 1, 2 dimethyl. So what is the parent chain of this carbon atom, of this catenation? You have 1, 2, 3, 4. So the parent chain is butane. I'm going to write butane. So the Iupac nomenclature is 1, 2 dimethylbutane and not 3, 4 dimethylbutane. So this is definitely not correct. This is more accurate and more correct when compared to this one. So what of if you have this, so I'll call here my methyl, I'll give here my ethyl, my hydrogen covalent bonding. So what of if we have something like this? How are we going to name it? So are we going to start, or are we going to name this from left to right or from right to left? So the correct answer to this question is from what? From right to left and not from left to right. Mind you, you can start from the back, you can start from the front, but for this one you're going to start from the front, which is from right to left, because we want to give this the possible lowest number. If we decide to start from the back, it starts to start from left to right. We have 1, we have 2, we have 3, we have 4, we have 5. So I'll have 3 ethyl and I'll have 4 methyl. But if I decide to number this way, 1, 2, 3, 4, 5, you see that I have 2 methyl and 3 ethyl. So which one is more smaller? Our aim is to give the substituents the lowest possible number, so we're going to use the 2 and 3 and not the 3 and 4. So now we have this. Go ahead and name it. Remember that here is a substituent called ethyl, so go ahead and name this. So I'm expecting to answer, which is 2 methyl, 3 ethyl. I have the parent chain 5, which is what? Pentane, which is alkane. So I'm also expecting this from different sets of people, which is 3 ethyl, 2 methyl, pentane. So only few we write this and many is going to write this. So between this Iupac nomenclature, which one is more accurate and which one is more correct? Is it the first or the second? So this first look something like that is correct, but is not definitely correct. The one that is correct is the second one. Why? In naming of alkane or in naming of organic compound, we name it alphabetical order. It doesn't depend on the number. So it depends on the alphabetical number. Alphabet. So naming two methyl and ethyl in alphabetical order, E comes before M. So writing M before E is wrong. You're going to write E before M. So the most accurate is this: 3-ethyl, 2-methyl pentane. Let's consider if we have something that looks like this. So how are we going to name? I have my ethyl here. I have my methyl. I have my hydrogen, and hydrogen. So go ahead and name this. The question is, where will you start the number? You can start from left to right, you can start from right to left, but for this compound we are going to start from where? We're going to start from the right to the left, and you can also start from the left to the right in this compound. Since I have one carbon atom and I have two carbon atom, and I have one and I also have two, so you can start from left to right and right to left, but methyl has more priority than ethyl. 1, 2, 3, 4. So how many methyl is here? I can find 3 in this molecule, which is 1, which is 2, and which is 3. So how am I going to name this compound? I have 3, so we're going to call it tri, not di. Now let's call it tri. So we are going to first, is it the trimethyl or ethyl? Let me write 2 possible errors students can make. So this is this 3-ethyl, 2, 2, 3 hyphen trimethyl, 1, 2, 3, 4 butane. And I'll explain this later. And 2, 2, 3 hyphen trimethyl, 3-ethyl butane. So which is more correct? Is it the first or the second? The first is more correct. When naming compound, you're not going to consider whether tri, whether di, whether pent, anything. What you're going to look at is the substituent itself, which is the methyl or the ethyl. You're not going to look at the prefix or the suffix there. What you're going to look at is the alkyl group or any other of substituents. So why did I write 2, 2, 3 trimethyl butane? So this is 3-ethyl. Ethyl comes before methyl, so that is why I have ethyl first, and ethyl is located at the 3 carbon atom. Now what of the 2, 2, 3 trimethyl? You know, because of I have 3 methyl, 1, 2, 3, I have tri. I hope that one is not confusing you. So how do I have this 2 to 3? I have this 2 to 3 because I have 2 methyl attached to what? The 2 carbon atom. So that is how I have that 2 2. Plus another, I have another methyl attached to the what? 3 carbon atom. That is how I have this 2 2 3 trimethyl butane. So let's go over to more, I say, complex. So go ahead and expand this structure. So your first question is to 1, expand the structure and write the molecular formula. I will have CH3. So expand. In expanding this, we have plus this attached to 2 hydrogen atom plus this is hydrogen, plus this. I have in that carbon atom, I have the hydrogen bond and the methyl bond. So I can decide to take the hydrogen downwards and methyl upward. I can also decide to take it upwards or in opposite direction. That doesn't really matter. So hydrogen, I have methyl. So and I have CH and H bond. So go ahead and name this compound. So what do you have here? Are we going to number from left to right or from right to left? So you're going to number from what? From right to left. And that will give this the lowest possible number, because if you number from left to right, we have 1, we have 2, we have 3, we have 4. So I will have 4 methyl, which is not actually what we want. If you number from this direction, I have 1, I have 2, I have 3, I have 4, and I have 5. So I have 2 methyl. So 4 and 2, which one is smaller? 2 is smaller than 4. So I will choose the lowest one because I want to give my substituents the lowest possible number. What is the name of this compound? So go ahead and name it. What do we have? We have 2 methyl what? Pentane. So I hope you're understanding this naming of compound. So here is a question for you. First, expand this structure here. CH3, CH2, CH2, CH, CH3, and CH3. So go ahead and expand. So after expanding it, name the compound the Iupac nomenclature. So to name this, let's first expand this compound. Expanding this compound, definitely we have this because of I have 2 hydrogen here. Because of 2 hydrogen. Then for the CH bond and methyl, I can take methyl and I can put methyl in any position I like, as far as it's about this carbon atom. So I have hydrogen here now. I have H, and I have H. So we have expanded this structure. How can we name this compound? So to name this compound, are we going to number from left to the right or from the right to the left? So tell me your answer, and also I want to know the Iupac nomenclature of this compound. So let's go ahead and name this compound. Considering coming from left to right, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So coming from right to left, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So if you observe this compound, you see naming from the left to the right or naming it from the right to the left, it doesn't actually affect the nomenclature of the compound, because we're going to have 2 methyl and 5 methyl coming from the left to the right, and we're going to also have 2 methyl and 5 methyl coming from the right to the left. So in this compound, you can come from the left to the right or from the right to the left. Now we have this. Let's go ahead and name this compound. So I will call this 2,5 dimethylhexane. I have my methyl, I have my hydrogen, and hydrogen. So go ahead and name this. The question is, where will you start the number? You can start from left to right, you can start from right to left, but for this compound, we are going to start from where? We're going to start from the right to the left. And you can also start from the left to the right in this compound. Since I have 1 carbon atom and I have 2 carbon atom, and I have 1 and I also have 2. So you can start from left to right and right to left, but methyl has more priority than ethyl. 1, 2, 3, 4. So how many methyl is here? I can find 3 in this molecule, which is 1, which is 2, and which is 3. So how am I going to name this compound? I have 3, so we're going to call it tri, not di. Now let's call it tri. So we are going to first, is it the trimethyl or ethyl? Let me write 2 possible errors students can make. So this is this 3-ethyl, 2, 2, 3 hyphen trimethyl, 1, 2, 3, 4 butane. And I'll explain this later. And 2, 2, 3 hyphen trimethyl, 3-ethyl butane. So which is more correct? Is it the first or the second? The first is more correct. When naming compound, you're not going to consider whether tri, whether di, whether pent, anything. What you're going to look at is the substituent itself, which is the methyl or the ethyl. You're not going to look at the prefix or the suffix there. What you're going to look at is the alkyl group or any other of substituents. So why did I write 2, 2, 3 trimethyl butane? So this is 3-ethyl. Ethyl comes before methyl, so that is why I have ethyl first, and ethyl is located at the 3 carbon atom. Now what of the 2, 2, 3 trimethyl? You know, because of I have 3 methyl, 1, 2, 3, I have tri. I hope that one is not confusing you. So how do I have this 2 to 3? I have this 2 to 3 because I have 2 methyl attached to what? The 2 carbon atom. So that is how I have that 2 2. Plus another, I have another methyl attached to the what? 3 carbon atom. That is how I have this 2 2 3 trimethyl butane. So let's go over to more, I say, complex. So go ahead and expand this structure. So your first question is to 1, expand the structure and write the molecular formula. I will have CH3. In expanding this, we have plus this attached to 2 hydrogen atom plus this is hydrogen, plus this. I have in that carbon atom, I have the hydrogen bond and the methyl bond. So I can decide to take the hydrogen downwards and methyl upward. I can also decide to take it upwards or in opposite direction. That doesn't really matter. So hydrogen, I have methyl. So and I have CH and H bond. So go ahead and name this compound. So what do you have here? Are we going to number from left to right or from right to left? So you're going to number from what? From right to left. And that will give this the lowest possible number, because if you number from left to right, we have 1, we have 2, we have 3, we have 4. So I will have 4 methyl, which is not actually what we want. If you number from this direction, I have 1, I have 2, I have 3, I have 4, and I have 5. So I have 2 methyl. So 4 and 2, which one is smaller? 2 is smaller than 4. So I will choose the lowest one because I want to give my substituents the lowest possible number. What is the name of this compound? So go ahead and name it. What do we have? We have 2 methyl what? Pentane. So I hope you're understanding this naming of compound. So here is a question for you. First, expand this structure here. CH3, CH2, CH2, CH, CH3, and CH3. So go ahead and expand. So after expanding it, name the compound the Iupac nomenclature. So to name this, let's first expand this compound. Expanding this compound, definitely we have this because of I have 2 hydrogen here. Because of 2 hydrogen. Then for the CH bond and methyl, I can take methyl and I can put methyl in any position I like, as far as it's about this carbon atom. So I have hydrogen here now. I have C, I have H, and I have H. So we have expanded this structure. how can we name this compound? So to name this compound, are we going to number from left to the right or from the right to the left? So tell me your answer, and also I want to know the Iupac nomenclature of this compound. So let's go ahead and name this compound. Considering coming from left to right, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So coming from right to left, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. So if you observe this compound, you see naming from the left to the right or naming it from the right to the left, it doesn't actually affect the nomenclature of the compound, because we're going to have 2 methyl and 5 methyl coming from the left to the right, and we're going to also have 2 methyl and 5 methyl coming from the right to the left. So in this compound, you can come from the left to the right or from the right to the left. Now we have this. Let's go ahead and name this compound. So I'll call this 2,5 dimethylhexane, because it's 6 carbon atom. So here is a one question you have to solve. Go ahead and name this compound. So I think this, and drop your answer in the comment section below. So here is a, let me decide to put here as my ethyl, let me put here as my methyl, let me put here as my methyl, let me put here as my methyl, let me also put here as methyl, and let me also put here as ethyl. So drop your answer in the comment section below. So name the compound, name the Iupac nomenclature of this compound, and drop your answer in this comment section below. What of if we have something like this? We call this the skeletal structure. Let me introduce something to you. So how many carbon atoms are here? So let's count. 1, 2, 3, 4, 5, 6, 7. So there are 7 carbon atoms. This is carbon to carbon bond. So that is why we have the first one to be what? 2. 1 and 2. The second one, 3, 4, 5, 6, 7. I hope you have understand how this skeletal structure work, because I want to bring out some dangerous naming of compound in skeletal structure. So what of if you have 1, 2, 3, 4, 5, 6, 7, and I decide to add here as this, and this. Okay, let me remove this, let me add this. So what is here? What is this? First, what is our longest continuous carbon chain here? Our longest continuous carbon chain is 1, 2, 3, 4, 5, 6, 7. So here I have heptane. So what is this? This is an alkyl group, the first member, known as what? Methyl. So anytime you see this, don't really expect you're going to have something like this. So they're not going to add something like this. So if I have this attached to my longest continuous carbon chain, I'll call this my methyl. If I have this, I'll call this my ethyl. If I have something like this, I'll call this my isopropyl. So these are some basic something you have to understand, because we're going to name some compounds now. So how are we going to name this? I have my methyl attached to the first carbon, second, and fifth. How am I going to name this? I have 2, I have 3, I have 5. So this will definitely be 2 comma 2 comma 5. Nope. This is not. This will definitely be 2 comma 3, because here is 3 and here is 2, comma what? I have 5 here, so I will put here 5 hyphen what? How many methyl do I have? I have 1, I have 2, and I have 3. So this will now become 2 3 5 tri, not di, not tetra. Tri methyl what? Heptane. So this is heptane. So what of if you have something like this? I'll decide to put here. So how am I going to name this compound? First, what is our longest continuous chain? Our longest continuous chain, should I number this way? 1 2 3 4 5 6 7 8, or should I go this way? 1 2 3 4 5 6 7 8 9. So our longest continuous chain, okay, let me try going this way. 1 2 3 4 5 6 7 8 9 10. You see that our longest continuous chain is this direction, is 10, which is what? Decane. So you have to be very careful in skeletal structure. So am I going to number from left to right or from right to left? So I'm going to number from left to right because I have a substituent here. So numbering, I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9, and I have 10. So now you have this. How are we going to name this compound? We have, this is a methyl group attached to group 2. So I have my 2 here, methyl, but I'm not going to call this 2 methyl because I still have another methyl here, and I have ethyl here, which is CH2 CH3. So ethyl always come before methyl. Now I have this. How am I going to name this? This ethyl is attached to what? Carbon 8. So I'll call this 8 ethyl hyphen. I have my methyl attached to carbon 3, and also I also have methyl attached to carbon 7. So I'll call this 3,7 hyphen di, because it is now to dimethyl 10 is what? Decane. So this is how to name this compound. So what of if we have maybe something like this? So how are we going to name this compound? Definitely. So first we're going to identify our longest continuous chain. So what is our longest continuous chain? So let's write from this direction. 1 2 3 4 5 6 7, and I have Coming from this direction this way, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I should decide to go like this, you see I'll have something like 1, 2, 3, 4, 5, 6, 7. So this is definitely not our longest chain. So our longest chain is this direction. Now we have our longest chain. How are we going to name this compound? Are we going to start from the left to the right, or from the right to the left? So starting from here, I have my ethyl. This is an ethyl. Ethyl, ethyl. So this is an ethyl group. Why this is an isopropyl? Which side am I going to start from? So if I should start from this direction, I'll have 1, I'll have 2, I'll have 3, I will have 4, I'll have 5, I'll have 6, I'll have 7, I'll have 8, and I'll have 9. So I'll have my ethyl at 5, and I'll have my isopropyl at 4. But if I should decide to name it this way, I will have my ethyl at 5 and my isopropyl at 6. So which one is more closer? 5, 6, and 5. So 5, 6, and 4, 5. Which one is more closer? Which one is more smaller? So it is 4, 5. Now I'm going to name this compound as 5-ethyl. Four isopropyl. What? Nonane. Let's talk about naming of cycloalkanes. So cycloalkane, we are just talking about alkanes that is in cyclic structure. Alkanes that are in or cyclic structure, or cycloalkanes, normally have formula CnH2n. But alkane has CnH2n plus 2. But these are alkanes that have what? That are called cycloalkanes because they're in because they have structure that is in cyclic format. So I'm going to use this formula for cycloalkanes. Let's decide that we have something like this. So what is this? This is called cyclopropane. 1, 2, and 3. So it's called cyclopropane. So what of if we have this? This is called cyclobutane. What of if we have this is one carbon atom? This is 1, 2, 3, 4, 5, 6. So this is called cyclohexane. let me draw the diagram where. So what of if you have something like this? I have 1, 2, 3, 4, 5, 6, 7. So this is definitely called cyclohexane. What of if you have substituents attached to all these atoms, all these cyclo? How are we going to call it? What are we going to call it now? So if I should have, for our cyclobutane, I have a methyl group. So necessarily I don't need to write methyl, because if you see this, always know it is a methyl group. Or let me decide to write methyl too as learners. So what are we going to call this? Are we going to start naming 1, 2? No, that is not necessary. Unless you have more than one substituent, that is when you are going to call this, or that is when you are going to start to number the substituents. But since we don't have more than one substituent, let's just go straight and call this methyl cyclobutane. If we have something like this, let me draw that diagram well. So if you have something like this, and I have an ethyl group attached to this, so what am I going to call this? The Iupac nomenclature of this is ethyl 1, 2, 3, 4, 5, 6 ethyl cyclohexane, because it is 6. Now you have basic understanding of naming of cyclo compounds. Let me go over to substituents with more than cycloalkanes with more than one substituent. So consider having this, our butane. You have, let me say, methyl, and methyl. So what is the name of this compound? So we're going to now start numbering this. So are we going to number from the left to the right? If you number from this direction, 1, 2, 3, 4. So I have 1, 2, 3. But if I should decide to number from this direction, 1, 2, 3, 4. So I have 1, 3, 4. So 1, 3, 4 and 1, 2, 3. Which one is smaller? You see that 1, 2, 3 is smaller. So the name of this compound will be 1, 2, 3 trimethylbutane. So I didn't say about something in naming of compound using Lewis structure, but I will go back as soon as we are done with this. Let's say we have something like this. And I have a chlorine, I have a bromine, I have a methyl group, and I have ethyl group. And maybe let me say I have another methyl group. So how are we going to name this compound? So we are going to name this compound in order to give it the lowest possible name. So if I should count from this direction, I have 1, 2, 3, 4, 5. If I should count from this direction, which means this direction will give me 1, 8, 4, 5. 1, 8, 3, 4, 5. That's what this direction will give me. But if I should decide to number from this direction, 1, 2, 3, 4, 5, I'll have 1, 2, 3, 4, 5 up. This is not 8. This is 1, 2, 3, 4, 5, not 8. So correct that. So both ways will give me the same direction. Now, what next? We're going to name this alphabetical order. So B, C, M, A. Which one comes first? B comes first, followed by C, followed by A before M. So to name this, in naming of halogens as substituents, anytime you see bromine, we call it bromo. Anytime you see iodide, we call it iodo. Anytime you see chlorine, we call it chloro. So now we have this. How are we going to name this? Bromine comes first. So this is 2-bromo. What next? Chlorine. 1-chloro. What next? Ethyl. 4-ethyl. What next? I have di. I have two, so I'll call it that should be 3,5-diethyl. But since I don't have enough space, so I'm going to create some space. So I'm going to name this. I'm going to write this very small. So now I have 2-bromo. 1-chloro. 4-ethyl. And I have 5 and I have 3. So I'll call this 3,5-dimethyl. So how many carbon atoms is here? 1, 2, 3, 4, 5, 6, 7. So this is what we call dimethylheptane. So the Iupac nomenclature of this compound here is 2-bromo, 1-chloro, 4-ethyl, 3,5-dimethylheptane. So this is the first part of this course. So the second naming of organic compound is coming soon. Don't forget to like, subscribe, and hit the notification bell for more videos like this on Sagashos Netherlands. So thank you for your time and thanks. Have a nice day.